Da skal vi bevege oss til et innlegg som heter Material Snapshots. Og der har vi fått med oss Kristian som kommer fra Henning, Larsen, arkitekter, og som Global Head of Sustainability and Innovation. Så han har altså hendene fulle, vil jeg tro. Kristian har også bakgrunn fra Snøhetta, så vi ble egentlig kjent med han i forbindelsen med Vertikal Nydalen, som det prosjektet som allerede nevnt. Det ikke det du skal snakke om i dag, men vi har jo åpnet for at folk kan komme og spørre deg om det etterpå på speeddaten. Så da får dere et fjes på han, så ta godt imot Kristian Edwards.
Morning, everyone. Just to add to Sigurdur's casserole of languages, I'm going to do this in English this morning. Thanks for having me. Thanks for the invitation to come and speak with you today. As Alan mentioned, I now work at Henning Larsen, which is a Danish, with Sigurdur, Danish company. Thanks to the previous speakers, it was very difficult not to just go into complete learning mode when Tario was speaking, for example. So hopefully I can remember what I was going to say. As mentioned, Henning Larsen, we specialize in knowledge-based design and have realized some 150 projects worldwide in various scales and typologies since the office was founded in 1969. We're 750 staff worldwide. Perhaps what you don't know is we're actually around 220, 230 here in Norway. Remember this one. So I'll give you a little background. I'm going to spend 15 minutes talking about 15 years probably of work, giving you a couple of very brief snapshots of a couple of experiences we have with low emission materials in practice through applied research in realized projects. The materials are less glamorous than this timber frame beauty being currently under construction in Sweden, world of Volvo, but are high volume, high area. And when we talk about scaling of low-emission materials, therefore all the more important. So a quick background, we talked about knowledge base. Over the last 15 years, we have 14 in-house industrial PhDs. Their topics vary on everything that we talk about in sustainability today, from energy design, social impact, CO2 and materials. Of course, that's kind of why we're here today, transformations and biodiversity, and there are plenty more in the pipeline. This is our expanding global team. Levi is here today. Martin Lewis, Katrine Julesam, and Kritika, many of these, and Jakob, of course, many of people that you probably know from various instances, all expertise in their fields. Our team is basically applying this design knowledge all around the world. Having this kind of overview from a global setup is extremely important as we can then apply sort of local knowledge. We understand that, for example, biodiversity in China may be very different than biodiversity definitions in Norway. The same goes for low-emission materials. What might be presented as low-emission here may be something very, very different depending on what's available to us. Having this global setup kind of keeps us in the balance. So we aim to sort of take a lead through knowledge creation and dissemination, open source, clear speech, and application of this knowledge. So you may know the unboxing carbon. We've already talked about the material pyramid. We have obviously some inputs in there. And contrary to what was mentioned previously, all of our staff go through an LCA coursing. We have expertise, but we also generally have understanding of numbers, which is extremely important when we're talking about low emissions, so that we're not making supposition, we are actually backing it up with numbers. Prototyping, of course, part of the reason we can talk the way that we do is actually we realize projects, we can disseminate them, we can break them down. Realization is always the best way to create an impact rather than simply talking about theory and supposition. We can't do everything all at once, but we can do something very well in every project, and that's something that we've already experienced this morning. Yeah, I can hop over this one. I couldn't go further without mentioning other prototypes in Norwegian context. You should be well familiar with the MA studios of Climate Form and In Balance studio run by Professor Tina Hegley here in the audience today, and her team, including myself, where we've actually tested some of these suppositions that are being proposed, circularity, low emission materials, low emission methods, let's say, ask any of the students who worked on this project with a 2-week build, 1 week spent picking out nails in -20, it generally sets an impression of how we're going to build these things. So we need to understand what we're talking about. This one, community greenhouse, having its inauguration now at the end of the month, understanding that sort of performance additives and building one-to-one. I'm not doing any of these projects any justice, but building one-to-one with double glazing frames and things like this, energy coatings and things like this actually turn out to be very toxic, so actually are dangerous to health, dangerous to handle, basically wasting valuable materials. We can talk about this one forever. I could have had a better picture for this one, but this is essentially resource refuge Agape built in Vardø as well, from drift lumber that's washed ashore, essentially all kind of good intentions to become a carbon negative or carbon sink or a carbon sequestering project, tilted in the balance, unfortunately, by simple fact that Swedish screws had come via Indonesian steel. It was enough to tip that into the balance. So more over to the projects that I'm going to talk about. This is the poster child, of course, of DEL&LÆR today, which is about straw. This one project is about straw. This is Sundby School in Denmark, using a technique from history, thatching. Straw in itself, of course, we've heard, is insulating, it's waterproof, it's non-toxic, and of course, being produced from single-season biogenic materials is, of course, a very valid way of talking about carbon capture. But it is not emission-free, and there's a lot of talk about waste products. We have to understand where they come from initially. So straw, of course, is a byproduct, is in some ways a waste product, but it also has an emission in terms of creating it. So numbers are extremely important. And of course, we talk about A1 to A4, particularly from Denmark. That's now legislation. I'm going to get back into that in a little bit of a second. So we talk about upfront carbon. This basically tells us more about, this gives us some transparency, it gives us some agency and understanding what we're actually specifying. But the straw itself, of course, we've heard this, we understand this, that in its inert form, in place, it has, of course, sequestered a large amount of carbon. This is, again, single-season biogenic material, so a lot of potential. Our agency is about design as well, to ensure that this project, or rather, not this project, but this material is protected. We understand this from when we design with wooden facades and things like this. The same goes for hay. Details are then important. This is really what we're talking about. But it's not to say that this in itself is a carbon negative material either, because once there is an EPD for this, we need to understand that this information is valid and certified. So this material in itself has an emission, even though it is a waste product or a circular product, however we want to talk about it. This method has, of course, a scale problem. It is, and in this case, it's craftsmanship that's lacking. So this is an ancient technique, and there are fewer and fewer and fewer people that can actually do this. In the UK, thatchers, there are just a handful left. So how can we use this very good material, straw, in large scale or scale it up industrial scale? We can talk about insulation. You probably know this project from Feldball School in Denmark, where it utilizes the eco-cocoon system. This project is almost entirely built from biogenic materials. And as an insulation material, it doesn't require that same kind of craftsmanship to put it together. It is, of course, this is wooden timber frame. We've talked about this modular setup. In 400 millimeters, it's actually a passive house or insulating level. And at the same time, in its inert form, it is sequestering quite a lot of carbon per unit. As such, we could argue is carbon negative, something like this. We talk about this relating to, okay, so this is a Danish project, so when we're looking at one and to the other, this is more standard than Danish. We talked about regional differences and things like this. We might compare this to a timber-framed house in Norway, for example. But there's a significant difference between one and the other. The materials, again, in an inert form, looking at the complete picture, it's still an emitting material just simply because of the way that it's dealt with at the end of its life. But it is a modular material. We can repair, we can reconfigure it rather. We can dismantle it, dispose of it in relatively simple terms. There's no additives, so we can burn it if we need to, and talk about heat and energy recovery. Or we could turn it into biochar and put it in the ground, extend its lifespan for 100 years, and make the soil more fertile for creating even more single-season biogenic material to improve that fertility. Of course, there are other headlines in this project as well, one of them being good indoor climate. We can fix the indoor climate. We can't fix the posture of the people using it, nor their mobile phone use. But here we see, of course, an abundance of timber, as we might expect, but also eelgrass has been mentioned, mycelium in acoustic panels, and clay plaster, of course, in finishes and things like this. And this results essentially in an upfront carbon accounting for the entire building of 6 kilograms of CO2 equivalents per square meter per year, which is pretty good. A1 to A4, I should mention. And this, of course, is then driven by legislation. In Denmark, they have set a ceiling for a 1,000 square meter building. There are ceilings that are being lowered for year on year. Norway, we have an accounting requirement, but we have no ceiling. And what's really driving innovation is exactly this, right? Limitation and legislation. Okay, so this is just checking the time here. This is obviously a slightly quirky project. It's small scale, it's 250 square meters. It's great, but what about scaling that? And in the subject of secret projects, I can tell you that we're using exactly the same techniques for a 150,000 square meter project in Netherlands, a logistics center. If we want to put that into context, like Norwegian context, we could talk about all these kind of big box things that are happening on the fringes of basically everywhere. So if we talk about replacing the next couple of generations problem materials with biogenic materials, then we can really start talking about scale, and in Norway. We mentioned eelgrass, acoustical boards. These also have an EPD. It's obviously an abundant material, carbon negative in its inert form. Over time, it also emits, but this is too expensive to use as insulation, at least in Danish context. They're very good at sequestering carbon, but then you have to keep them going. And beauty is part of that discussion. We've experimented with mycelium acoustic boards in replacement for these lovely tiles that we see all over the place, understanding that the composition of these tiles with the substrates and things that we do develops different kind of porosities and different qualities for dealing with acoustics. We tested some of these in 3D spatial, or rather, we discussed testing them in somewhat 3D spatial elements, which as a spin-off from the FutureBuilt Naturligvis project, and Nydalen Vertical was one of those projects where that was considered to be put into practice. We can also compress this material down to, I'm going to use it slightly a little bit longer, I'm sorry. We can compress this down to be material that resembles MDF, but of course, and gypsum board, and consider how that might be possible. But of course, this material, in the way that it's made and things like this, doesn't have EPDs. So can we conscientiously use it? I think that's a question we have to ask ourselves when we're talking about low emission materials. If we're not talking numbers, what are we talking about? So alternatives to this, of course, there's a little theme. We're going to talk about that in a second. But I read recently that there were 420,000 square meters of gypsum board used simply in the renovation cycles of the Empire State Building. That's quite a lot of material. Gypsum board, as we know now, has more recycled components. You can specify 100% recycled gypsum board, so this number, of course, is coming down. This is all important incremental changes that we need to make. Clay boards, for example, as an alternative, are more or less approaching some form of carbon neutrality. And surprisingly, when we only look at A1 to A4 and upfront carbon, OSB board, that old chestnut, suddenly is a carbon sequestering material. Only when we look at the bottom line, which is the total lifespan of this, we understand that waste scenarios for this material also make it very difficult. So if we don't have numbers, we're only making suppositions, and we need to be very, very clear, otherwise we will be greenwashing our projects. Imagine then mycelium boards in this kind of context. We can intuit as how well they'll work, but we don't entirely know until we have EPDs and material going. I've got flashing red lights everywhere. Okay, we've understand some of these statements that are being made, and of course this is somewhat true. We're seeing some relevance happening here, and 70,000 people. To achieve some of these statements, we have to be building a city for 1.5 million people per week. And to imagine that this is going to be created from wood entirely is somewhat of a challenge. I'm not sure that there are enough trees to do this. And I'm pretty sure I'm wrong, but monoculture, the productive forests that we're talking about are diminishing biodiversity where they are planted. They also burn particularly well. We might have noticed some of that happening in recent times, but it's all the more reason to talk about large volume materials and biogenic materials at scale as being part of the solution. It says closing. I just wanted to bring, seeing as we're talking about experience in this part, I was actually here last week and talking to the head of sustainability, director of sustainability of one of the largest development companies in New York City. We talked about building performance, where US is kind of behind Europe and particularly the Nordics and things like this, but we're also talking about materials. And if there's one thing that America can do, that's scale. And I was particularly encouraged to learn that this developer themselves was actually bankrolling their own testing and certifying of something called ground glass pozzolans, which is an alternative to concrete, a non-Portland cement-based concrete, where they basically crush grind waste glass to become, we talked about corn stirrers and things like this, to become a geopolymer with an alkalic activator. To 12,000 psi, which is not just laying it on a screed, as a screed layer. It's much more interesting to talk about that as rammed earth. But actually, at 12,000 psi, you're talking about New York scale, large building, foundation level grade materials. And that's when we can start to talk properly about scale. In a Norwegian context, we have geopolymers in the pipeline. I'm sure you guys know about Safe Rock and things that are happening, not just them, but others as well. And big changes are about to happen. It will only be driven, or rather, it will only be expedited by legislation. So please, Norway, let's put a cap on our CO2. That's all from me. Look out for some more events coming up from us in the coming year, not least changing our footprint exhibition opening in Copenhagen in 2024, but also coming here to Norway in the third quarter of 2024. Thanks a lot. Looking forward to hearing what Matthew says.
Tusen takk. Vi rekker et lite spørsmål til deg også. Altså, hvis det Kristian snakker perfekt norsk, det glemte jeg å si, så det ikke noe flaut du må ikke snakke engelsk for å spørre.
It's just the vowels before 12.
Der har vi et fra Sigurdur der borte.
Grunnlaget for lavkarbonbetong i Norge, eller et av på en måte argumenten, det flyvaske, som et overskuddsprodukt.
Yes, which hopefully will be phased out in very short term.
Det jeg enig i. Men så det på en måte, når man ser på halm, at halm blir aldri på en måte dyrket til å ta ut halmen, det blir alltid dyrket for korn. Så på en måte at halm burde man ikke se på med samme øyne på flyvaske, som man ser på flyvaske på halmen som et absolutt overskuddsprodukt, på en måte i måten man regner og ser det på? Eller gjør man det alltid, og jeg bare misforstår hele greia?
I think we have to take that in speed dating. I'm not quite sure how to frame that out for you, but it's definitely a discussion we should have.
Det kan bli en lang date. Tusen takk, da kan du gå og sette deg.